Great, and thanks again everybody for joining us here today for this webinar. Again, the title of today's webinar is Serverless Application Building and Deployments with AWS SAM, and my name is Chris Munns. I'm currently a Senior Developer Advocate for Serverless here at AWS. I've been at AWS just a little over 6 years now across a couple different roles based in our New York City office, previously having represented our DevOps product suite from business development role, and started back in 2011 here as a solutions architect. But actually come from more of a traditional kind of operations, or maybe what today people would consider to be a DevOps or SRE engineer type of background. But for the last year and a half or so, I've been really focused on the space of serverless, and I find it to be the most exciting thing that's going on in the industry today. So before we dive into SAM completely, let's actually talk about this term of serverless. What does it mean? What is its potential impact to you? Again, this is right now kind of a hot term in the industry. We're seeing a lot of interest across kind of all different fronts and what serverless might mean. And here at AWS, we actually have what I consider to be a pretty firm definition of what serverless is. So for us, serverless pretty much comes down to 4 guiding principles. No servers to provision or manage. This means no physical, no virtual, or no containers that you as an operations person or as a developer, as a business, should need to think about. Should scale with usage, so as requests or activities or events come in for whatever your application might be that it's doing, platform or products that are serverless should automatically be able to scale to handle those requests and execute whatever logic they need to. You should never have to pay for idle. There's stats that show that across the industry, large swaths of enterprise IT resources actually sit idle an overwhelming majority of the time. In the case with serverless, what it means is that you shouldn't have to think about capacity planning such that you have to plan for idle. So you'll never have to think about planning for an amount of idle capacity that you'd be paying for, which greatly reduces the amount of cost. And then lastly, availability and fault tolerance built in. For us here at AWS, we have a concept of regions and availability zones. Typically, when you're building an application inside of AWS, you are building across typically what we call 2 or more availability zones inside of a region. In the case of serverless products, that high availability and fault tolerance is going to be built in. So when we look at these 4 kind of key factors for what shapes serverless, what they give you is, again, a reduced amount of responsibility in terms of traditional infrastructure management, a much better alignment with cost based on the needs of the application, and ideally better fault tolerance and availability than if you hypothetically had to configure it yourself and deal with the consequences of that. The center of the serverless universe for us here at AWS is AWS Lambda. So AWS Lambda is, at the end of the day, a compute service. And when we talk about a serverless application, it exists around Lambda essentially as the core of that application. And so typically a serverless application is made up of at least 3 components, sometimes just 2 though. So you'll always have some sort of event source. So this is something that is going to invoke our Lambda function via either say something like a change in data state, changes in the resource state, requests to endpoints, calls to the Lambda API. You then have your Lambda function, which is code that you have written in one of the 5 languages that we show supported here, or potentially one of the languages that the community has written a third-party plugin for. And then what your code does is clearly up to you. So whatever it is that your business logic needs to accomplish, whether it be talking to databases or data stores, other HTTP or HPS endpoints out on the internet, basically kind of any service that you might need to call inside of a network, that is something that you as the developer can completely control. And so these 3 key components here, again, is how we think about what the kind of logical bundle is of a serverless application. And so today when we're talking about a serverless application, we'll be talking again about at least the event source and the function, and or potentially what it might be that that function is talking to. And so Lambda has a pretty straightforward programming model. There's basically just 3 key aspects to a Lambda function that you need to think about. First, there's the handler function. This is kind of the core of your code's logic for serving your business needs. Essentially, this is the entry point for the business logic inside of your code. We see here an example of a very basic handler that takes in 2 different variables, book and context. It then goes and calls another function. In this case, we can think of that as our business logic that lives outside of this handler, and then it's going to return back to the invocation source some sort of output from this. And so the handler function is typically where you will take in whatever data and event sourcing and context that you have. We'll talk about the context here in a moment. Do whatever business logic it is that you might need to accomplish, and then return the result back out to the invoking service. Now, the event object is a key part of this, and so depending on the invocation source that you have, it is going to pass in a different event source, again, in alignment with what it is that that invocation source is passing you. So an API gateway is going to pass you an event object that would look like an HTTP request and various attributes from it, whereas an S3 event object is going to pass in information like the bucket and key value. And then lastly, we have the context object. And so the context object is a number of methods and bits of information that are available to you that you can use inside of your function to help interface with kind of the surrounding compute environment around it, such as the log group, information about the request ID, the timeout of your function, and so forth. And this allows you to do some different kind of more custom things inside of your function's logic. At AWS, we talk about security being our #1 priority, and with products like Lambda, it's no different or no exception, I guess I should say here. With Lambda, there's basically 2 core concepts when it comes to how you think about security of your Lambda function. There's what your Lambda function can do, what services it can talk to, whether they be databases or data stores, and then there's who can invoke your Lambda function. Essentially, will I allow my Lambda function to be invoked by Kinesis, or by an API gateway, or say just directly by the API? And so the execution policy and the function policy are 2 core aspects to how you configure your Lambda function. And you definitely want to spend time thinking and understanding what's possible via IAM and the resource policies that are aligned with this. And so when we talk about the configuration of our Lambda function, the responsibilities around configuring the permissions model are something that you as a developer need to spend time thinking about what you're doing there. Going along with how we talked about there being event sources, there's actually a number of different execution models that Lambda can support as well. So we support a synchronous model, an asynchronous model, and then a stream-based model. And how you build your application and which of these models you think about and which invocation sources you might be picking for your Lambda function are, again, going to completely relate to what it is that your application needs to do. In the example here with the synchronous model, we have an API gateway in which, let's say that we get an API call that goes to /order on our URL path. That's going to then invoke a Lambda function corresponding to that path, which will do whatever business logic it needs to do and then return a response to us. And our API is going to expect a response back to whatever the client might be. In an asynchronous event, we see examples here with, say, Amazon SNS, or Simple Notification Service, Amazon S3, Simple Storage Service, where we get either, say, a message into a topic in SNS or an object put into an S3 bucket, which is going to generate an invocation to our Lambda function. Now, our Lambda function is going to process the event or process the data from the object potentially and do whatever it might need to do, again, based on your business logic. But we're not going to expect the Lambda function to respond back to the originating client of those 2 services. So in this case, this is an asynchronous model. It's just simply going to process the request, and then what you do with that later on is up to your application's logic. And then lastly, with stream-based, we support with today Amazon DynamoDB and Amazon Kinesis, and soon Amazon SQS, which will operate kind of similar to these 2, the ability for you to follow directly onto a stream, again in the case of DynamoDB and Kinesis. What happens here is the Lambda service actually pulls these 2 resources, or the resource depending on what you've configured here, pulls records out and acts upon them, such that you can do near real-time computation on, say, data that you're streaming inbound on a Kinesis stream. In this case, again, you're not expecting your function to respond back to the originating service. You're just expecting it to complete the business logic that you're looking for. And so there are a number of different event sources that trigger AWS Lambda. Something around 30 different AWS services today can be have the ability to invoke a Lambda function on behalf of itself or of your application. And so there's lots of different ways that Lambda can glue into, again, your infrastructure and your application across these. And we're not going to go to all these today, but it's important to understand the complexity that exists between all these different event sources, the security model for Lambda, your code and how it's written, and how your code is executed in terms of the invocation model that exists for that invoking service. And across this, when you put these all together, there are a number of common use cases that we see for Lambda and for serverless applications. Web applications, so the backend behind things like single-page web apps, or even more complex web applications, it's very common to see Lambda used with API Gateway in this way. Backends, so backends for, say, mobile applications, for IoT devices, for internal API-based, say, microservices for an infrastructure. It's another very common use case. Data processing, so batch, real-time processing, MapReduce, one of the largest use cases of Lambda today. Chatbots and Alexa, both pretty similar. We see customers that are increasingly building chatbots for interfacing both internally and externally from their organizations. Amazon Alexa is obviously an incredibly powerful home AI device, or AI service, I should say, that lives in lots of different devices today, from TVs to Echo devices to all sorts of things. And then IT automation. Typically, this looks like Glue or things that react to, say, policy-driven services such as CloudTrail or config and config rules that can allow you to respond and automate certain actions inside of your infrastructure. And so if we combine, again here, the various different invocation sources with the invocation models with our Lambda function and the two different types of security controls that it has on top of it, across these various different use cases, there's a lot of different ways that we can configure Lambda inside of our infrastructure to do lots of different things for us. And so when it comes to this complexity, we want to think a lot about how it is that we can manage this complexity and how it is that we can, essentially tame it and make it easier to deal with. And so now it's time to get kind of to the meat of today's presentation, which is AWS SAM. And so SAM, as we see represented here by our wonderful little squirrel mascot, which is also named Sam. You'll see SAM showing up in all sorts of places these days. But what is SAM? So SAM stands for Serverless Application Models. And what SAM is actually an extension today that is built on top of CloudFormation. CloudFormation is a template-driven service for deploying, managing, and updating resources inside of AWS. And so SAM is built on top of that with a number of special resource types and other capabilities, which we're going to talk about here today. It's important to note, though, that just because SAM is built on top of CloudFormation, it actually supports all of the resources that would typically be part of CloudFormation. So it is not itself a separate product or a separate infrastructure management tool, so much as it is a simplification layer on top of it. We'll talk about that here in a moment. Also, SAM itself is actually an open source project, and we recently open sourced the entire SAM translator, which I'll talk about here a little bit more towards the end of today's webinar. And you'll see how you can actually contribute code back to this project and kind of grow the capabilities of SAM. So what does a SAM template look like? Well, this is a really kind of brief example here, and we're going to highlight kind of the main aspects of this SAM template. The first, as we see here at the top, are the headers that we have. So we see the template format version, and then we see the second line here, which is a transform. This is actually kind of the most key part about the headers for a CloudFormation template with SAM. So a transform tells the CloudFormation service that this is something special that you need to look at, that you're going to look at then the resources in this template and potentially treat them differently. And so inside of SAM today, we have three special resources that get treated differently: serverless function, serverless API, and simple table. And we'll talk a little bit more about all of those here today as well. In this example then, there are then two resources that we have that are being created by it. The first is of that type, serverless function, and then the latter is of the type simple table, which you see all the way at the bottom here with the name list table. Now, in the case of the bottom one, what it's going to do is just create for us a simple DynamoDB table with the base 5 read and write units. If we look, though, at the middle section here with the resource that's called getHTML function, what this does is a little bit different. So in this case, we've got some properties that are part of what would be configuring a Lambda function, such as the code URI, the handler, the runtime, the policies. And then we have the event structure. So we see that we have an event called getHTML. It's of type API, and it has properties that look like an API definition. And so what would come out of these approximately less than 20 lines of code is a Lambda function, an API gateway, configured to work together with a policy that will allow this Lambda function to access DynamoDB tables, and then down below we actually create a DynamoDB table. And so again, instead of you having to go and click through the console or even write this in raw CloudFormation, which if you were to write this in raw CloudFormation, it would be roughly approximately 50 to 60 lines of code to put all of this together. This less than 20 lines here greatly simplifies the work that you would need to do in order to accomplish the same outcome. Another way to think about this is from an example that we have out in GitHub today for a demo that is called AWS Serverless Farm. And in the SAM farm demo, we have a SAM template, as we see here kind of on the left. And if we think about the meat of the SAM template, the main kind of resources that we're creating, we see from roughly lines 9 through lines 25, similar to what we saw on the last slide. So the definition around our serverless function. So we see the handler, the runtime, the code URI, we're passing in environment variables. We'll talk about those a little bit here later as well. And then the event source. And what this actually translates to and we see on the right-hand side here a screenshot from the CloudFormation Designer, is approximately 7 resources that are going to get created by running this template. And again, if you were to configure this in the console or via the CLI or via CloudFormation, you'd be doing a lot more work than just writing what you see here in lines 9 through 25. And so SAM really does help you in simplification of defining your serverless applications, in building the model for them, and in, as we'll see here in a little bit, being able to deploy them. Let's go a little bit more in depth here on the 3 main template properties that exist. So we see here a serverless function, and this actually does not include all of the bits that you could configure today. But one thing that's really important to note is that you don't have to configure all of these things. One of the key things that SAM does is it assumes that a number of same defaults are going to be applied. So for example, if we don't define memory size or timeout, it's just going to take some very basic defaults and apply those. If we don't find a policy, it's going to assume a very basic execution policy for us. But then what we can still do is get down and kind of configure some of these more specifically for our application. So for example, turning on tracing for X-ray, actually setting the memory or timeout. You still have the ability to configure those if you so desire. For a serverless API, there's a little bit less that you can do here, but you still have exposure to a number of the capabilities. So for example, we see here a cache cluster, whether it's enabled and the size that you'd have, an endpoint configuration. You can also set a number of things such as headers and so forth for your API. But again, you don't have to in this case. And then lastly, for a simple table, we see some of the various parameters and attributes that we also want to configure, such as the primary key, provisioned throughput, tags, and if we're going to turn on SSE with this DynamoDB table. So again, simplification allows you to reduce the amount of lines of code that you're writing and should make it much easier to get started with configuring your serverless applications. Now, with a serverless function, you have the ability to configure directly the event source. And again, there are a number of different event sources that exist inside of AWS today. And so SAM really focuses on enabling you to configure the most popular ones that we see. And actually, when we cover things such as SNS, S3, Kinesis, and API, this actually covers an overwhelming majority of the use cases that we see with serverless applications. And so pretty much all of these have something very similar in structure. You have a type, and then you have properties for the event. So we see here an example of an S3 invocation event being configured here, where we reference a bucket itself. So if we look at S3 a little bit deeper, what we can define is the bucket. We can then also filter by a number of supported events. And the documentation covers all of these, whether it be delete object, update object, new object. There's a number of different ones that you could put in. You can also then filter based on things such as the prefix or the suffix in terms of the path of where that object lives inside of your S3 bucket, essentially the key structure. This is an important thing to watch out for when you are building S3-driven Lambda functions. It's actually somewhat easy to accidentally create a Lambda function that causes a recursive behavior. And so you want to think about when you are reading objects from S3 and then writing them back into S3, either writing back to a different bucket or back to a different prefix or suffix, and then making sure that the rule for your event is filtering out those new objects that are being created. Otherwise, you can create a loop where you would take an object from a bucket, process it, put it back into a bucket, and end up processing it again. So just a minor tip to watch out for. SNS, pretty straightforward, takes the SNS topic that this Lambda function is being consuming from. Kinesis and DynamoDB, both very similar in terms of the syntax for these. You specify the stream, the starting position, the batch size. I'm going to skip down here to schedule. So this is for a scheduled function inside of CloudWatch events. This is one of my favorite use cases for Lambda, as I've run cron servers for many years in my life. And so what you could do here is actually use Lambda and CloudWatch events to replace cron and essentially create scheduled Lambda functions. One interesting thing you can do with this is you can call, for example, the AWS run command inside of your Lambda function such that it can execute commands on, say, traditional servers running on EC2, whether they be Linux or Windows, from inside of Lambda on a scheduled time. And so it opens up all sorts of possibilities for what you can do with scheduled Lambda functions. And then lastly, this is kind of a fun one here. So Amazon Alexa Alexa skills can be powered by Lambda. The Alexa team says that Lambda is the easiest way to create and build an Alexa skill. It's actually a lot of fun to do. I've done it myself for Alexa devices that I have at home. And so in terms of configuring your Lambda function with SAM, all you do is specify the type. And that basically tells your Lambda function that it should be able to be invoked by Alexa. So after you have built and created this template that you have, you typically don't want to do something with it. And so a little over a year ago, we actually launched a tool that was called AWS SAM Local. Much like the name sounds, it allows you to be able to do local development of serverless functions, something that can be kind of tricky when you think about the fact that most of the serverless services that you're interfacing with, especially with Lambda, are primarily completely hosted. And so what SAM Local allowed you to do was to essentially take your local Lambda function and your code based on your SAM template, create a Docker environment that would allow you to execute your Lambda function locally. And it could create either a basically fake local proxy style API endpoint for you by running a daemon on a local port, or you could pipe JSON documents to it and invoke functions as if you were invoking, say, from SNS or S3 or Kinesis. And so it gives you a really good way for you to be able to test your serverless applications and validate they're working properly. Now recently, just back a couple of weeks ago on May 8th, we relaunched SAM Local, now called SAM CLI. And so the SAM CLI gained a number of capabilities. It has a much stronger validating capability, such that you can validate your SAM templates in a greater depth than you used to be able to. It's also got some increased capabilities in terms of being able to help you get started with a serverless application, being able to init a new application. And I want to show that to you here today. So before we dive into it, this is just a screenshot of what happens when you execute SAM. So I'm calling here SAM-help. And one of my favorite things I think about the SAM tool is that it actually has really awesome help guidance. So for any of the commands below, you can just throw a --help on it, and it's going to explain to you all of the sub options that exist inside of it. And so you can really kind of work through and learn how to use SAM as part of this. You can also directly use SAM to package and deploy your serverless application. So being that SAM is built on top of CloudFormation, there were two underlying commands that were added to CloudFormation as part of this, CloudFormation package and CloudFormation deploy. Now what package does is it looks at your SAM template and it takes your application repository and it zips it up and puts it into S3 for you. And then what deploy does is it then takes that package up in S3, it takes a then what's considered transformed CloudFormation template, and then it goes through the process of standing up the CloudFormation stack for your SAM-based application. And so this is how you can directly from your command line, essentially, create, build, test, and deploy your serverless application. So let's dive into SAM here real quick. Great. So in order for this demo here, I'm going to use Cloud9. So AWS Cloud9 is an IDE-based product that we have. What it gives me is actually an EC2 instance running a really powerful IDE that is very deeply integrated with the AWS environment, a number of AWS services. So what I have up top here is my text editor window, and it has just the basic README file for a new application or a new Cloud9 environment. And then down below here what I have is shell on the EC2 instance. And so this is a normal shell environment, and it comes pre-installed with SAM, and I've actually gone through and recently updated the SAM version on this. So it has SAM version 0.3.0, which is currently the current one. And so let's go ahead and make this a little bigger and go and show how we can work with SAM. So again, if I run SAM-help, that's going to give me the help interface for SAM. I can see here again all of the commands which I had talked about previously. We've got init, package, local, validate, and deploy. So actually go and create a new SAM package or a new SAM-based application. So if I do SAM init help, I can see here all of the things that are possible with using the init command. And so the init command is actually going to go and create a brand new serverless application for me. So if you're just getting started with serverless and you're brand new to this, it's actually a really great way for you to basically get the initial scaffolding of a serverless application without having to think about it. So for example, you see here that I can specify the runtime, I can specify also, for example, here external locations such as those that are on GitHub or in Bitbucket or in other places. In this case, what I'm going to do is I'm just going to create a new SAM application with Node.js and get that started here. So I'm going to do SAM init-r and Node.js 8.10. Great. So now what this has done very quickly here is given me a new SAM-based application. So I can go into SAM app, and I can see all of the files that are here inside of this directory. I have another directory called Hello World. I have a README and then a template file. Now if I come down here on the left, I can see also inside of the environment the files that have been created. So let me minimize this. So built into Cloud9 is actually an editor for SAM templates. So we see this right here. I have my function, a description, the handler for it. I can configure the memory this function needs, as high as it might need to go. In this case, I'm just going to say 512. I can specify a specific role or allow my function to create a role for itself. The other thing I can do here is say, you know what, I'm kind of old school. I want to edit this as a text editor, and so I can turn on just what's called the ACE text editor. And so here I see my actual SAM template. Again, this is the one that was provided for me by SAM init. And I can go through and see how this was configured, see the events that were passed in, see some various aspects. So for those of you who are completely new to CloudFormation syntax, this is actually a pretty rich example in terms of a run-through of some CloudFormation syntax. So we have a function inside of SAM that's called sub, and what it's going to do is replace the text that is in these parentheses here, curly brackets, with the values that represent those resources. And so again, this is going to get me started with a very, very basic application. Now, I can actually tell SAM to check my template and make sure that it is a valid template. And so it's going to go and tell me that that everything is good. So SAM, or my template, is a valid SAM template. Now again, with SAM, I have the ability to do things such as package up, test, validate my local command. I can also, again, do things like generate false invocations to pass at it. Given that I'm not going to go too in-depth into creating my application here, we'll just kind of leave this as is. But again, super straightforward to get in here and fire up the SAM interface to generate an application and then to start to work through using this application. Great. And again, you can get started right inside of the Cloud9 environment. You can deploy directly from this environment. You can pull in other existing applications from your Lambda environment inside of this. And so it is a really straightforward and easy way to get started with doing serverless development. So I had talked a little bit before about how SAM is built on top of CloudFormation. CloudFormation itself is actually a really incredible product at AWS. It's got a lot of different capabilities. We see here is a very, very basic CloudFormation template actually, and I don't expect you to be able to read this really small text on the screen. But what I do want you to get from this slide is that a CloudFormation template actually has a number of different capabilities that can be put inside of it. And so this template right here actually contains aspects of 6 of those capabilities. So headers we've already talked a little bit about, kind of tells the underlying service what it might need to do for this product and understand what capabilities are inside of this template. Parameters are the next section. We have mappings, conditionals, resources, which we talked a little bit about here, and then outputs. And now your template may not need all of these sections, but it's typically going to need a couple of them. So again, headers, descriptions of what your stack does, contains, transforms, and so forth. Parameters are provision time values that are passed in at execution. These could be things like passing in, say, the name of an application, passing in identifiers of other resources, all sorts of things. This is the stuff that adds kind of dynamic capabilities to your templates. Mappings you could think of as predefined conditional case statements. This is stuff where, let's say, based on a parameter, you want a template to behave a certain way in relation to another piece of data. Say that you want inside of a dev environment for a function to be configured one way, and inside of a prod environment for it to be configured a different way. You could specify, say, a parameter called environment, and then based on the mapping, provide a value down to the function configuration itself. Conditionals are values that are set based on evaluations of past references. You could use conditionals to do interesting things, such as when to decide to create or not create a certain resource. So maybe, for example, again, going back to the environmental concern that you might have, you might want to create a certain resource or set a certain parameter inside of dev that you wouldn't want to set in prod. And you might want to do that based on another factor. Let's say that the application is an API-based application and it's going to run in prod, and so you're going to create, say, a certain execution policy. The resources, again, these are the AWS resources that your template is going to create. These are things such as your Lambda functions, databases, VPC configuration, IAM policies and roles, all of the end AWS resources themselves. And then outputs are the resulting attributes that come out of a stack. You can think of it as kind of a way for you to understand what it is that your stack just did, such that it could be consumed potentially by other CloudFormation stacks, or just provide information to you based on, again, things like the name of a Lambda function or the endpoint for an API. So again, you can mix in all these capabilities with SAM. You can mix in non-SAM CloudFormation resources in the same template. So things, for example, as S3 buckets, Kinesis streams, step functions configuration, VPC configuration, IAM, even EC2, RDS, you name it. SAM supports the ability for you to use parameters, mappings, outputs, conditionals, metadata, which is another bit of CloudFormation that we're not going into here today. It also supports the intrinsic functions. So we saw before that FN sub. There's a number of these functions that allow you to have dynamic capabilities as part of your CloudFormation template. And you can also use what's called import value. So as part of the outputs, we support the ability for you to have what are called exported outputs. These allow you to then be able to import those outputs inside of another stack just by passing in the reference to them. And so this allows you to essentially glue together various stacks. Imagine, if you will, that I had a template that represented databases, and then I have a template that represents my CloudFormation, my serverless application resources. I can actually reference that database identifier from inside of my SAM template by using the import value. Today with CloudFormation, we support two different DSLs, YAML or JSON, and so you pick whichever one works for you, and both of them are supported with SAM. So let's talk a little bit more about some of the capabilities of these templates and how you might use them. So inside of Lambda, we have what are called environment variables. Pretty straightforward. They're key value pairs that allow you to pass information down to your function. And the way that they are then processed inside of your function is via standard environment variable APIs. So for example, process.environment for Node.js, OS environment for Python. Again, depending on what your language is, you're just going to use the basic commands to pull in the environment variables that you would find on the OS itself. We support encryption of these via KMS or AWS Key Management Service, such that you could use these to store, say, secret information, as it were, such as API keys or password information. Although I'll say that we also have two other services that are a bit more purposeful for this, AWS Parameter Store and then Secrets Manager. But these are really useful for doing things such as creating environments per stage, for doing feature flags, and for doing application level configuration that maybe isn't of as secretive a nature, such as passwords or API keys. Now, going along with this, we also have a similar capability in API Gateway called stage variables. And so stage variables are also key value pairs that can be accessed as part of your API Gateway configuration. They can also be passed down in the context object to, say, a Lambda function or in the request back down to an HTTP endpoint. And so when you put these two together, it allows for a high level of dynamicness based on, say, creating individual environments across your software development lifecycle. And so how this works in SAM is that we could specify, for example, here, two different parameters. We have a parameter called myEnvironment. We then have a parameter, or we have a mapping actually here called special feature 1. And the way that these show up inside of my SAM template, which is on the right-hand side of the screen here, is as environment variables, both for my Lambda function and my API gateway. And so we see here for the Lambda function, kind of the top half of the right side there, we have an environment variable called environment. It then is using an intrinsic function called ref, or reference. It's then going to reference the parameter called myEnvironment. Below that, we see an environment variable called special feature 1, which aligns then with the mapping. And this is actually using now two different intrinsic functions. First, find and map. So this is going to use a mapping. In this case, it's going to use the mapping called special feature 1, which you see here on the left. It's going to then combine my parameter called my environment and pull out the value called status from the mapping. So based on the environment that's been passed in, whether it's testing, staging, or prod, it's then going to pull the status value out, which we see here based on testing, staging, and prod is either set to on, or off. And then that will be passed down to my Lambda function itself. And so my Lambda function, upon either its initial bootstrap or every time that there's an invocation, can grab these values and configure its business logic accordingly for that. We then also see down below at the bottom half of the right-hand side of the screen where I have an API gateway definition where I'm passing in the environment variable from my environment, and we can assume that that somehow impacts my application in some way. And so again, by combining these parameters and these mappings with the ability to pass in environment variables and stage variables to Lambda and then API gateway, it gives us a heavy capability, or essentially a great capability for having very dynamic templates that can be reused over and over again in lots of different ways. So we actually combine this to do some really interesting things. One of the other capabilities that we have here of SAM is something called safe deployments. So safe deployments are a capability built on top of a functionality of Lambda, which is called alias traffic shifting. And so inside of Lambda, we have the ability for you to say, take a certain percentage of traffic and shift it to a certain version alias of my code. And this allows you to do really kind of great, safe, controlled deployments of code out to, say, a very small percentage of your customer base without, say, flipping the switch on all of the traffic going to a new way. And so with this, what are required are two key things. One is that you need to set the auto-publish alias attribute inside your SAM template. And we see that set here previously. The auto-publish alias is set to the reference for environment. So I'm going to create an alias based on this environment type. And then the second is the deployment preference type. In this case, how quickly essentially do I want my code to be deployed out? And so we have a number of pre-configured options for you here. So you see, for example, Canary 10%, 30 minutes. What this says is I'm going to deploy out to 10% of my traffic for just 30 minutes. And then you see various different versions of this. So Canary 10% 5 minutes, Canary 10% 10 minutes. And then we also see a linear model for deployment here. So linear 10% every 10 minutes means that every 10 minutes I'm going to ramp up the traffic by 10%. And so if we go back to the previous slide here, we can see that we are doing that linear 10% every 10 minutes. So safe deployments actually gives you a little bit more than just this. And so down below where I had defined the speed at which I wanted to do my deployment, I also have the ability to have this deployment basically be watching certain alarms inside of my AWS account. And so I can have, say, alarms that are based on my serverless application such that if I'm doing a deploy and something goes wrong, it will actually halt and undo that deployment for me. And so I see here that I have two alarms that I'm referencing, and I'm referencing them by the name of the alarm. One is called alias error metric greater than 0 alarm. The next one is called latest version error metric greater than 0 alarm. And you can actually specify up to 10 different alarms that you might want to watch about a given application and use those to gauge whether a deployment should go forward or not. In the case of, say, a Canary deploy where I've deployed out to a certain percentage of my traffic, if one of these alarms were to fail, then it will roll back. Otherwise, it will continue to go forward. Another capability that I have here is the ability to execute Lambda functions as part of my deployment on a hook. And so we see here a pre-traffic and post-traffic hook. I can use these Lambda functions, for example, to put a message into, say, a chat system saying that a deploy is about to happen or that a deploy is completed. I could update, say, a CMDB or a ticketing system. There's a number of things that I could potentially do with this. Another good capability here of SAM is something called SAM globals. So we see here in the top left, I've highlighted a section of code here. And if you look into the various attributes that are defined, you'll see that these are all attributes that exist for Lambda functions. For example, here at the runtime, the code URI, the memory size, the timeout, turning on auto-publish alias for safe deployments. And so by putting these inside of the globals, these actually impact all of the Lambda functions that you see defined here. So when you look at the 3 Lambda functions that are defined, you'll see that I actually do not have any of those attributes defined in them themselves. And so what you can do with globals, much like it seems, is define standards for an application inside of a SAM template and have them be deployed continuously or evenly across all of those functions. Now you can overwrite these. If you look at the get birds function in the bottom right, you'll see that it actually has its own timeout specified. And now this is just an example. I can't come up with a good reason as to why this template maybe or that function would have a different timeout, but you do have the ability to overwrite any of the aspects of the global, and the attribute as defined inside of the actual resource itself does get priority. But if I wanted to add more functions to this SAM application, all we need to do is provide the name of it, the type, the property with the handler, and then an event structure. And so it saves me from having to write that much more inside of this template. It will help keep my templates lighter and cleaner over time. Another great thing that I have inside of SAM is something called SAM policy templates. Now, I mentioned earlier when we talked about the two kind of key aspects of security for Lambda, the execution policy and the function policy. In the case of my functions policy, or essentially the execution policy here for what my function can do, I'm concerned with what it is that it might be able to access. In the earlier example that I showed you of a SAM template, I showed a policy that would have allowed my function to read from any DynamoDB table. Now that might be way too permissive inside of my environment, and so I would typically want to scope it down to a single table. And so what we've done with SAM policy templates is we've created a number of predefined policies that take an attribute, and then this greatly helps you simplify what it is that you need to do from a policy creation standpoint. So we see here that this policy is called DynamoDB CRUD policy. And what you can actually do is reference back in GitHub this policy into what it will actually do for you. And so I'm passing in here a table name referencing my table, which is a simple table at the bottom of this SAM template. Now if I go into GitHub and pull up the policy template itself, I can actually see here what it is that the DynamoDB CRUD policy gives me. Well, what it gives me is all of the things to be able to do, essentially create, update, and delete actions on a given table. And we see all the way down here at the bottom of it, down below line 119 of this document, that I'm actually going to essentially peg this capability or restrict this capability just on the resource defined. In this case, it's the resource called table name that I'm passing in here. And again, we see table name being passed in. And so there's a number of these policies that exist inside of this policy template. We feel that it covers a good number of some of the default use cases for Lambda serverless applications, but this is one area we're always looking for guidance and a great opportunity for people to contribute to SAM itself. But either way, these policy definitions will greatly simplify, again, the code that you have to write inside of your SAM template. So let's talk about some general best practices here real quick. So in terms of building and creating your templates, parameters and mappings are really key for being able to make your templates be highly dynamic and highly reusable. We see an example here of a SAM template that can be used in a dev, test, and then prod environment. Being able to do that really does require heavy usage of parameters and mappings to help enable your template to have that dynamicness based on the environment that it might be in. Use the global section as much as possible to help simplify where it is that you're doing repetitive lines inside of your template. You can set a number of same defaults inside of the globals, and then where necessary, overwrite them as required. We didn't go too much into it in this talk, but imports and exports in CloudFormation are incredibly powerful for you to be able to glue information about resources across stacks. And so get into a habit of exporting values and looking for how you can import values, again, just to simplify actually the parameters and mappings that you might need. When it comes to actually building serverless applications, building out multiple environments for development, test, and production is a best practice that is actually, I feel, easier in serverless than it is in traditional compute-based applications, largely for the purpose of the fact that it's not a resource that you have to manage in the same way. With a serverless application, you don't have, say, an EC2 instance running 24/7 that needs to be patched and monitored, and that's costing you money. In this case, you'd only be paying for the invocations of the serverless application when you're testing it in that given environment. So again, building this capability is into your template such that it can be used for various environments, and even for, say, things like disaster recovery is really key and something you should aim for. When it comes to organizing your SAM applications, this is something that I find a number of customers sometimes struggle with trying to figure out. So one thing is that unless your function handlers for a given application share code, split them into their own independent Lambda functions. Essentially, try to avoid doing any sort of request routing inside of the handler for a function. This lends itself to a number of bad practices if you do that. Another option here is to actually make use of things like language-specific packages to share code between different functions. So let's say that I have an API, and my API correlates with 20 different Lambda functions, or 20 different capabilities, I should say, of APIs. They should each be represented by their own Lambda function that would exist inside of a single repository, making use of, say, another shared library to talk to some other backend system. Second bullet point here, which states that use independent Lambda functions, unless independent Lambda functions share an event source, split them into their own code repositories with their own SAM templates. So given the previous example of having, say, a serverless API driven by 20 Lambda functions, if I also then have the need to, say, process data off of a Kinesis stream, that should be its own application. That shouldn't necessarily share any sort of code or logic with my API workload. And so in that case, split them into their own repositories with their own SAM templates based on the invocation source. Lastly, because these templates are based on YAML or JSON, you have the ability to validate or lint them before committing them. So I showed very briefly here using the SAM validate tool. There's a number of other tools that exist out there that will go and validate just regular YAML or JSON. I actually encourage you to have a pattern of validating the template with one of those tools. So lint your template, then validate your template with SAM, and then be comfortable committing it and putting it towards your build process. And then in your build process, you always want to make sure that you're doing these steps as well, and that prevents you from sending any bad templates to the CloudFormation service, which would potentially slow down your test, dev, and debug cycle. So that's it for best practices. I mentioned earlier that we recently open sourced the SAM translator. So again, behind the scenes, what happens when you take a SAM template and you send it to the CloudFormation service to launch your resources and manage your stack is we have to translate those SAM resources into the underlying CloudFormation resources. And so before a couple weeks ago, the SAM translator was something that we maintained internally that was a kind of black box capability. But recently, as of a couple of weeks ago, we have open sourced the SAM translator. You can actually go and view kind of all the aspects about what the code does and how it takes those simplified resources and expands them, how policy templates work, how globals work. All of that can be found inside of this. And so our question to you is, what other resources do you want to see become essentially SAMified? What else can we do to simplify the process of managing SAM serverless applications? But what's great is you can actually go and put in pull requests yourself for these capabilities. And we're already starting to see some pretty awesome examples from the community. Again, we just open sourced this all back on May 8th. And so a couple of pull requests have been merged in already. We see a couple that I just took screenshots of a couple days ago that exist out there. And so these are from awesome people in our community. And we love seeing this and hope that, you can come in and issue pull requests and ideas for other capabilities that you'd like to see added to SAM. Going along with this, back in April, we also made generally available the AWS Serverless Application Repository. And so the AWS Serverless Application Repository is a place where you can go and find all sorts of pre-built applications that are serverless. So they're built on top of Lambda. There's a couple of hundred in these here today. Some of them are from third-party companies, individual developers, AWS developers and service teams, across kind of a number of different use cases. And you can actually just immediately go and launch these inside your AWS account in just a couple of clicks. And so actually one requirement for getting applications into the Serverless Application Repository is that you do have to have a SAM template. And so SAM is powering essentially the deployment process for these serverless applications. And if you want to go and learn and understand more about building serverless, the application repository is also a great source for that. Because we link back to the source repositories for all these applications. So you can see the templates, you can see their code. And again, it's a great place to share applications. And so hope to see folks contributing more and more to this here in the near future. So we talked about a whole lot of things here very quickly today in relation to SAM, serverless application models. Again, SAM is a template-driven model that allows you to define almost every aspect about the underlying infrastructure and resources for your serverless application. We've also talked about SAM CLI, the local test development and deployment tool that we have for SAM that allows you to do everything from create a brand new project to testing that project locally to being able to then go and deploy that project eventually. We talked about some of the capabilities that come with CloudFormation, the thing that underpins SAM itself, from parameters and mappings to outputs, and some of the capabilities and how you can use that to build highly dynamic templates that can become really powerful in the management of your infrastructure. Lastly, we've covered a number of best practices, so thinking about what belongs inside of a single serverless application versus, say, multiple serverless applications. And again, some of those best practices from a template side of things. Pretty much everything that I've talked about here today, though, could be found at our main page for serverless at aws.amazon.com/serverless. We have here links to developer tools, to resources such as other webinars, blog posts, talks that have been recorded at events that we have, as well as links to various different third-party frameworks in the developer tools space, partners that exist of ours across both the ISV and SI consulting space. And so I encourage you to head there to find out more about serverless if this is a space that you're just getting into. If you have any other questions, though, that you don't find answers to there, you can feel free to reach out to me. Again, my name is Chris Munns. I'm the lead developer advocate for serverless here at AWS. You can find me at munns@amazon.com or at Chris Munns on Twitter. Happy to try to address any questions that you can. I want to thank you all for coming here to today's session. Hopefully you've been asking questions as we've been going here. We've been able to answer those for you. Again, feel free to reach out to me online or via email, and want to thank you again for joining us here today. Happy serverless application hacking, and look forward to seeing you at a future webinar. Take care.